This lesson is about space figures and cross sections. The objective is to recognize polyhedra and their parts and to visualize cross sections of space figures. So, first definition is a polyhedron. Polyhedron is a space figure or a three-dimensional figure whose faces are polygons. So each polygon is called a face of the polyhedron, and an edge is a segment that's formed by the intersection of any two faces. A vertex is a point where three or more edges intersect. So there's a figure below to show a polyhedron that has in its faces and its edges and its vertices. There's a Swiss mathematician called Leonhard Euler. Let's spell his name. Leonhard. Leonhard Euler. Euler. And he discovered a relationship among the number of faces, vertices, and edges of any polyhedron. So this is called Euler's formula. So in Euler's formula, the sum of the number of faces and the vertices of a polyhedron is 2 more than the number of its edges. Now this is in 3 dimensions, okay? So I'm going to put a 3D out here beside this formula. If it will also apply to 2-dimensional if you have the net of a 3-dimensional figure and you lay it out flat. And we'll go ahead and give you that as well. In 2 dimensions, its faces plus vertices is edges plus 1. That's in 2D. You may need to use that for some of your exercises as well. The last definition here is a cross section. A cross section is the intersection of a solid and a plane. So you can think of it as a very thin slice of the solid. So let's look at some problems using this. In problem 1, it asks you how many vertices, edges, and faces are in the polyhedron below, and to list them. So let's look at the solid that they gave us, and it says, if we look at the points where the edges meet, so the points where any 3 edges meet are the vertices. There are 4 vertices in this, and they are point R, point S, point T, and point U. The edges are the segments where 2 faces meet. So we have 6 edges. And let's name those. They are the segments RS, so I'm going from the top down. RS, RT, RU. Now let's go to the bottom segments. Along the base, there's segment ST, segment TU, and segment US. So those are the 6 segments that represent the edges. The last thing it asked are for the faces. The faces of this polyhedron are all triangles. There's 3 that are lateral faces. Those are the ones on the sides. So, and then there's 1 on the bottom for the base. So that gives us 4 faces. So we have 4 faces. And let's name those. And you need to name them as triangles because that's what they, the polygons that represent the faces in this one are. So it's RST, triangle RST, triangle RTU, triangle RSU, on the back side. And then on the bottom, it's triangle STU. So that illustrates vertices, edges, and faces of this polyhedron. On problem 2, you're using Euler's formula to determine how many edges the polyhedron has. So look at Euler's formula. This is in 3 dimensions. It's the number of faces plus the number of vertices equals the number of edges plus 2. So to calculate this using Euler's formula, we need the faces and the vertices to determine the edges. There's 4 faces on the top of this polyhedron, and there's 4 faces on the bottom. So that gives us 8 faces. And the number of vertices, if you count the number of points where any 3 edges meet, the vertices, it has 1, 2, 3, 4, 5, 6. There's 6 vertices. So we can use that to calculate the number of edges without having to count the edges. So that gives us 14 is equal to the edges plus 2. So that means that there are, if you subtract 2 from both sides, there are 12. There are 12 edges on this polyhedron. On the next problem, you're describing a cross-section. So it gives you a diagram, and it asks what is the cross-section formed by the plane and the solid below. So the solid is a cone, upside down cone, I guess. It's the point vertex of the cone is at the top. And the rectangle that's drawn represents the plane that is cutting through the solid cone. So if you outline the part that is going, that the plane is intersecting, that is going to be the cross section. So here we have a triangle cross section. On the next one, it's asking you to draw a cross section formed by a vertical plane intersecting the right and left faces of the cube. And what shape is the cross section going to be? So the first thing you need to do is draw a rectangle representing the plane that is intersecting the cube. So I'm going to go straight across the top down to the bottom, and I'm going to put dots for the part that we can't, that's going through the solid. So there's the plane that is intersecting the cube. So now let's look and see what the figure is, what the cross section is. I'll draw that in blue. So the cross section that's formed by this plane, it's intersecting it, that's going to be a square. So we will look at some more examples of this in class. It'll make it easier to visualize this and see it.